All right, so we can also, not only can we try to solve them to find inverses, but we can also use composition to see if we can verify whether they are inverses of each other. So let's say we had the function f of x is equal to 3x plus 9. And let's say we have the function g of x is equal to 1 over 3x minus 3. So what I want to do is verify whether these two are inverses of each other. So what I'll do is I'll use the composition f of g of x. So what I'm going to do is plug into 3x plus 9. I'm going to plug in g of x in here. So this should be 3 is 3, and in parentheses 1/3 x minus 3 plus 9. So now we're going to solve, or we're going to simplify. First we distribute. And so what happens here is 3 times 1/3 will cancel out, and we're left with x. And then 3 times negative 3, which would be negative 9. And then negative 9 plus 9 actually cancel out as well, so we are only left with an x. If you are left with one single x, then these two will be inverses of each other. Now let's do another example with two that are not inverses. So let's say we had f of x is equal to 4x squared and g of x equal to 2 square root of x. So I'm going to do it again where we're going to do f of g of x. So what we're going to say is that we're going to plug in g of x where x squared would be. So this would be 4 and then 2 square root of x squared. So what happens here is that squaring that square root will basically cancel that out, and then 2 squared, which would be 4. So we would have 4 times 4x. We distribute, we end up with 16x. So as you can see, we are not left with a single x. We still have 16 there. So because we don't have, we would say that they are not inverses.